Ladies and gentlemen, hello. Since my last video on the Pakistan Airlines Flight 8303 accident has gotten a bit of interest, I thought I would make another video to dive into the subject of energy management and possibly how that airplane arrived so high and fast in the terminal area and what pilots normally think about and how they manage the descent to get down to an altitude where they can make a safe landing at a safe speed. Let's talk first about energy. Obviously, flying an airplane involves many aspects of the sciences. We're going to talk a bit about physics and energy management. Essentially, when we take off an airplane and fly to another airport, we're going to burn fuel. That fuel is going to convert chemical energy into kinetic energy, which is speed, and potential energy, which is altitude. Both that speed and the altitude are relative to the Earth. So, an aircraft sitting on the ground, stationary, at the gate, has neither kinetic energy or potential energy. If the fuel tanks are full, it would have plenty of chemical energy, potential chemical energy stored in those fuel tanks. So we take off and climb and use the engines to get speed and altitude and take that aircraft up to cruising altitude. A typical aircraft cruising at 450 knots or so, ground speed, and at an altitude of 34,000 feet, has lots of kinetic energy and potential energy, which can be used for the descent to make that distance from top of descent location to the airport location where the plane is going to land. So the task for the pilots flying the aircraft are to reduce both the potential energy, the altitude, and the kinetic energy, the speed, from those high values at cruise down to relatively low values during the approach, and then land on the runway with low enough energy in the touchdown zone such that the brakes and thrust reversers can slow that plane and it can turn off safely on a taxiway and make its way to the gate and disembark all of the happy passengers. So we have to think about what's the distance to the destination? How high are we? How fast are we going? And there are some rules of thumb. There are different techniques. A lot of that is managed in the computer on the aircraft. In the computer, it's going to consider the cruise altitude, consider the winds encountered by the aircraft in the descent. After all, headwinds are going to slow the ground speed. Tailwinds are going to increase the ground speed. So you have to work through all of that and manage the total energy of the airplane. We'll keep the calculations relatively simple and assume we're descending to an airport near sea level. In that case, our target would be 30 miles away from that airport at 10,000 feet. That's 3,000 meters. And a speed of 250 knots. Now, some airports are above sea level. For example, Denver in the USA is about a mile high. Other airports are even higher than that. So the aircraft has less descending to do from 10,000 down to the field elevation. A prudent crew is going to manage their speed so that they can fly rapidly above 10, get into the local area, slow down before descending below 10,000, and still have enough distance between them and the airport to safely slow the aircraft and configure and land. Now, I have another target that I like to use in the descent planning, which has served me well over the years, and that's to aim for a point 8 miles from the runway at 2,000 feet above field elevation and a speed above 180 knots. With that target in mind, plan on a 3-to-1 descent angle. That means for every 1,000 feet of descent, use 3 nautical miles. So to descend to sea level from an altitude of 34,000 feet, we would need about 102 miles. That's strictly for the descent. We also have to think about speed. I like to add an extra nautical mile for every 10 knots of ground speed above 180 knots. Another variation on the technique is to add a nautical mile for every 10 knots of tailwind, subtract 1 nautical mile for every 10 knots of headwind. To do that, you have to think about the winds from cruise all the way down to the ground, essentially. To do that accurately, you have to have wind forecasts and consider winds at each level all the way down into the terminal area near the airport. And the plan of action is to descend, slow down the aircraft, configuring is done incrementally. You slow down when you need to reduce below the minimum speed for clean flight. Extend flaps incrementally. On the 737, we would use flaps 5 in the terminal area while we're maneuvering to set up on the approach, about 180 knots. Good operating practice is to have the airplane in level flight and ready to join the glide path from below. So you essentially set everything up and you wait. If you're going to hand fly it, you simply wait for the instrument indications to show that you're coming up on the glide slope, and you join it and fly it. At some point after that, you'll lower the gear, increase the flap setting to what you're going to use for the landing, fly the approach. If you're flying the aircraft on autopilot, then the machine is going to do the flying. The pilots are going to configure and monitor that autopilot and watch and make sure it does the proper things. They'll wait for the indications to show that the airplane is joining the glide path. And then they're going to extend the gear and the final flap setting. They'll monitor the action of the autopilot, and as it nears the runway, they'll disconnect, fly manually, and land the aircraft. If they're doing an auto land, well, they'll monitor and make the proper call-outs to each other and make sure the autopilot flares and lands the airplane. Now, there are some safety considerations. Number 1, at the top of the list, is you manage the energy so that you are never too high and too fast in the terminal area. You certainly don't line up on the runway and dive down to join the glide path from above. That rarely works out. The airplane is almost always too fast to continue configuring. You'll have problems with the speeds. Some aircraft do not slow down very well at all, even at idle power. It can really turn into a mess. So think ahead. If necessary, slow down early, configure early. If the crew needs more space to do that, they can talk to air traffic control and get delaying vectors. If air traffic control doesn't want to directly supervise it, they can work out a deal and get a holding pattern and descend in the hold. And when they're ready to fly the approach, come out of that, join up, and land. Stabilized approach has several factors to it, and they can vary somewhat between different airlines and from country to country as the regulators expect certain criteria to be met. Generally, the expectation for a stabilized approach is that the aircraft will be established before 1,000 feet on the glide path, configured for the landing at a power setting that'll keep the speed stable down the approach, and that no abnormal maneuvering is required. And in fact, the pilots are expected to use small, precise pitch and roll changes to track the glide path and center line of the runway down to the airport. The approach is not stable if unusual power settings are necessary, if extreme pitch or bank is necessary to track down to the runway, if the aircraft is not actually staying on the proper path, if it's drifting left or right of track. Sometimes those can be caused by turbulence, adverse winds, wind shear. Wind shear is not always caused by thunderstorms. Even something as benign as a warm front or a cold front can cause shifts in winds. Temperature inversions can be associated with wind shifts, so there are several factors in that. The heart of the matter is that the crew should establish that airplane on a stabilized approach by 1,000 feet, and if they cannot do it, then abandon the approach. Go around, or if they haven't gotten deep into the approach, simply talk to ATC and get a higher altitude, turn, go out, set things up again, and make another attempt. And if they're absolutely not able to get in because of adverse weather or mechanical problems or other problems, well, go to another airport where a safe landing can be made. And that's it. That's my brief talk on energy management for the descent from cruise down to the airport. I hope this was helpful. If it is, click like, subscribe, come back for more videos. Bye-bye.